This is a basic tutorial on 5 of the chemical reaction types. There are more than 5, but we're just going to cover these 5. The first one is synthesis. It's also called combination or addition reaction. It's basically when you're taking elements and you put them together to form compounds. Decomposition is the opposite of that, when you're taking compounds and you're breaking them up into their elemental forms, or in a case of polyatomic compounds like carbonates and chlorates, you're going to break them up into simpler compounds and elements, not always down to the basic elements. A single replacement reaction, you're going to have a single anion or cation in its stable elemental form, and it will take the place of either the cation or the anion in a compound. And so if you look at this, this would be representing like a metal. A metal would replace the other metal in the compound. So now in the end, you're going to have the metal in the compound, and the metal that was in the compound will now not be in the compound. You could also do this with nonmetals. In that case, you could think of it as like the female replacing the female in the compound, and the female would be left out. So this is the basic structure. In a double displacement, it's a situation where you have two compounds, and again, the cations are always going to be leading the compounds no matter where they're written, on the left or the right, but they switch partners. And so if you think of this as a metal and this is a nonmetal, this metal will then bond with this new nonmetal, and this metal bonded with that nonmetal, and this is the basic structure. The last type of reaction is a combustion reaction. Combustion reactions that we will study always have oxygen as a reactant, and they will always produce carbon dioxide and water as products. They also produce heat and light as energy, but we typically don't write that in the reaction. It's just something that's assumed whenever you have combustion. Well, let's quickly look at our periodic table because this is going to be helpful. The cations are located on the left-hand side and the middle of the periodic table. So these are all going to be ions that will give up electrons in order to bond and become stable, whereas the anions are mainly in this upper right corner. Whenever they bond, they're going to take electrons in order to be more stable. So let's practice identifying types of reaction using this worksheet you can find on the internet. So in this case, this is a metal, and this is a nonmetal polyatomic. This is a metal, this is a nonmetal polyatomic. And so the cations I've underlined in green, and then the anions or the polyatomic anions I've underlined in orange to help indicate what kind of reaction. So you can tell that there's a green and orange partner and a green and orange partner, and in the end they switched partners. So the sodium used to be partnered with phosphate, but now the sodium is partnered with hydroxide. So this is a double displacement or replacement reaction. It's called either one because they switched partners. The potassium and the sodium stayed in the front of the ions, but these two anions switched places. Again, you've got a compound, and then in the end, you also have two compounds, so it has to be a double displacement or double replacement. They're called the same thing. And so magnesium used to be bonded with chlorine, but now magnesium is bonded with carbonate. And so again, the anions or the polyatomics switch places. Now this is one that we just talked about, where you always have oxygen as a reactant and carbon dioxide and water as products. And so this is going to be combustion. In this reaction, you have a cation all by himself. Now in this case, he's not truly a cation, he's lead metal, but on the periodic table, when he goes to bond, he will bond as if he were a cation. So that's why I have it underlined that way. So you have a cation, when he bonds, he would be a cation, and he ends up bonding with the only anion, the polyatomic here. Then this iron is left out, and so this is iron metal. So this is a single replacement or displacement because one of them was single and then there was a couple, and in the end you still had a single element and a couple, but they're different. All right, this is a one compound that is broken down into two smaller or simpler compounds, and this is called decomposition because you can think of decomposing. All right, this decomposition reaction, and this is a very common decomposition reaction. Notice that the carbonate here breaks up into carbon dioxide and then the metal oxide. That's something that you probably need to memorize because that happens a lot. Most decomposition reactions will simply break down into the two elements, the 2 or 3 basic elements in there. But in this case, notice it didn't break down into calcium and carbon and oxygen. Carbonates will always, in nature, break down into carbon dioxide and then the metal oxide. So that's something that you would need to know if you had to predict the product. In this case, you have phosphorus, which is acting like an anion if it were in a compound, and then oxygen also is an anion, and you put them together and make a covalent compound, diphosphorus trioxide. When you take smaller elements and put them together into a more complex compound, this is called synthesis, or we also call it addition reactions or combination reactions. In this case, you have two couples. You can think of them as couples. You have a couple here and a couple there, or compound. And then in the end, you have two couples again. Again, rubidium and beryllium always have to be written first in the products because they're the cations. Cations are always written first, the green before the orange in each of these cases. But their partners have been changed. So rubidium was with nitrate, now rubidium's with fluorine. Now notice that whenever the compounds are reformed here in the products, you don't take the subscript with it. The compounds are formed because the electrons must be balanced between the bond. And so please don't make the mistake of just taking the 2 with the fluorine and the 1 with the nitrate, because that would be an error. Whenever you put them together as products, you have to actually look at your oxidation numbers or your charges, and you crisscross and bond them correctly. Then after you bond the compounds, you go back and balance. So think about that. All right, this next one, this is a double displacement. This next one has a compound and something single, and you end with a different compound and something different that's single. So this is single displacement or single replacement. In this one, it's already color-coded for you. Notice that you have a hydrocarbon, which means that it's a compound that has hydrogen and carbon. Sometimes it has oxygen, sometimes it doesn't. You combine it with oxygen, and you get carbon dioxide and water as your products. So this is obviously a combustion reaction. You also get a lot of energy in the form of light or heat, like fireworks or fire in your fireplace. Those are combustion reactions. In this case, it looks kind of odd. This is a hydrocarbon, but then you also have a metal with it, and you put them together to form a more complex ion. And so this is going to be either a combination, you can think of it as a combination reaction, an addition reaction, or we often call it synthesis. The next one you have, this is an interesting one to pay attention to because you have a compound and you have an element, but this is an anion. So in this case, this anion, this oxygen, can replace the chlorine, and the chlorine can replace the oxygen. It's a single displacement reaction, but don't get into the habit of just throwing the single in front. A lot of single displacement reactions are with metals, but not all of them. So if you compare it and contrast it to question number 8, this was a metal, which is a cation, and the cation can replace the other cation. So they can switch places. In this case, these are nonmetals, and so the nonmetals have to switch places. And so selenium is still selenium, but the oxygen and the chlorine get to switch places here. So be careful about that when you're predicting products. Here you have a compound, and you make 2 new compounds, so that's double displacement or double replacement. This last one, you have one compound, and it breaks down into smaller parts, And so this is going to be decomposition because it's breaking down into simpler elements or compounds. And then in this last one, you have nitrogen dioxide, and it breaks down into oxygen and nitrogen elements. And so this again will also be decomposition because it's breaking down into smaller parts. I hope that's helpful. Again, remember that the 5 basic kinds of reactions are synthesis, decomposition, and they're opposites of each other or reverse. Single replacement always has a single and a compound, and you end with a different single and a different compound, but the cation is still first. Then you have double displacement where you switch partners, and then the last one is combustion, where you always have oxygen as a reactant and you make carbon dioxide and water, and it produces a significant amount of energy in the form of heat and light.